Next is weak acid and strong base. That is, the next derivation is based on the weak acid and strong base. Here also follow the same principle. Explanations are given, examples are given, but the derivation is based on a general principle. After that, one example will be given to you. Follow all the 4 steps, derive the equation, arrive at the final result. Then try to do the numericals or the assignment given at the end of this discussion. Now, sodium acetate, sodium cyanide, sodium benzoate, etc. are the salts of this type. 4 examples are given. And they hydrolyze in water and form an alkaline solution. Fill in the blank question can be asked. Weak acid, strong base, the alkaline solution. The hydrolysis of this type of salt can be understood by considering the example of sodium acetate. Therefore, the example you are supposed to write is based on sodium acetate. Sodium acetate, CS3COA is a OONA, is a salt of a weak acid, acetic acid, and a strong base, sodium hydroxide, when dissolved in water. It dissociates almost completely into CS3CO- and Na plus ions. CS3CONA is a strong electrolyte and dissociate into, because of one side arrow, CS3CO- Na plus. Acetate ions being conjugate of a weak acid, that means acid base. Acetic acid is an acid and CS3CO- plus liberating an H plus ion. Therefore, it is a base and an H plus is formed, and both becomes conjugate pair. Act as a strong base, that means this, and have a tendency to accept H plus ion from water to form weakly dissociated acetic acid. Now, CS3CO- act as a base, strong base. Only bases can accept proton. Therefore, CS3CO- accepts a proton and becomes weakly dissociated acetic acid. CS3CO- from the water accept H plus and form CS3CO-, CS3COH and OH minus. Excess of OH will be in the solution. Therefore, in order to compensate the loss of H plus ion, because acetic acid is taken away all the H plus in the water, the undissociated water molecule gets further dissociated to maintain the constant value of Kw. This increases the concentration of OH ions in solution and the solution becomes alkaline. Give reason question. The nature of why it is alkaline, you have to explain this. This is the reason. Now we are going to step by step. Step 1. Hydrolysis constant. The hydrolysis of salt AB of a weak acid HA and a strong base BOH can be represented as A minus plus H2O, reversible arrow, HA plus OH minus. Applying the law of equilibrium, K is equal to concentration of HA into concentration of OH minus divided by concentration A minus into concentration of water. Bring the water to this side to the equilibrium constant, means it is known as KH. Thereby we got KH. KH is, that is K into water is equal to KH. Concentration of HA into OH minus divided by concentration of A minus. Equation number 1. We got one value, that is KH.